Hey everyone, have you ever looked up at the night sky and just been like, whoa,
Yeah.
like that feeling of awe, but also maybe like a little bit overwhelmed, you know what I mean?
Yeah.
Like trying to grasp the family history of, well, everything. How far back does that go?
Right. Billions of years.
Billions of years, exactly. So today we're not doing a straight up timeline of the universe. It's more like uh, we're eavesdropping on a conversation the universe has been having for like ever.
Hmm.
We're gonna deep dive into that human obsession with space, that, that curiosity we all have about what's out there, that desire to know, but also not wanting our brains to explode, trying to understand it all.
Right.
It's a lot to take in, right? So we've got this amazing collection of thoughts and ideas, bits of history, mythology, science, all about that human quest to understand the cosmos. So settle in, grab a drink, whatever makes you comfy, and we're going to take a kind of fun and hopefully funny look at our relationship with the universe.
Okay. That's good.
Less of a lecture, more of a cool cosmic road trip.
I like that.
So this fascination with space, it's a pretty human thing, right?
It really is when you think about it. This need to understand the universe seems to be like baked into us, you know?
Mm.
And look at science fiction. It taps into this duality, right? The fear of the unknown,
Oh.
all those alien invasion stories that really get under our skin.
Oh, yeah.
Playing on those primal fears.
Yeah.
But then there's this incredible sense of possibility,
Right.
this excitement about what else is out there.
Oh, hope.
Yeah, yeah, exactly.
Yeah.
So you have something like The War of the Worlds, pure anxiety about the unknown.
Oh, yeah. Scary.
And then you have E.T. or Close Encounters offering a sense of wonder and connection.
Right. Right.
And it's fascinating that it all boils down to the same question. Are we alone, but explored with these totally different emotions?
Totally. It's that mix of what if it all goes wrong with imagine what we might find.
Exactly.
And this isn't new either. People have been stargazing forever. Think about those old star charts, so detailed, made by hand.
Incredible.
Now we've got, space programs and telescopes and all that. But it's the same core desire, just fancier tools.
Yeah.
I remember as a kid being totally captivated by that Star Trek intro with Captain Kirk, to explore strange new worlds, to seek out new life and new civilizations,
Like
to
great.
boldly go where no man has gone before. It just captured that urge, that human need to explore.
Yeah, that cosmic curiosity.
Right? Exactly. And if we look back, the understanding we have today, as crazy as it is, came from people who dared to question everything,
Oh, yeah.
who looked at what everyone accepted and said, wait a minute, what if it's not like that?
The rebels.
The rebels, exactly. It was a shift from just believing to actually, thinking scientifically. And the early glimmers of that were in ancient Greece.
Yeah, the ancient Greeks really laid a lot of the groundwork for how we think about science and the universe.
For sure. It's easy to forget that what we know now didn't just appear. It's built on centuries of people going, I don't think so.
Right. Challenging the status quo.
It reminds me of this thing, and this is totally made up, but when I was a kid, I thought constellations were like actual pictures in the sky.
Huh.
Like someone had drawn lines between the stars. I pictured them connected.
Oh.
And then later I realized it's just patterns we see from Earth, and the stars are actually light years apart.
Right. They're not actually close together at all.
It was a real mind-blowing moment realizing how far we've come from those more imaginative explanations.
Yeah. Well, those imaginative explanations played a role too.
Hmm.
Think about those early attempts to explain the universe using natural laws, even if they seem a bit off to us now.
Okay.
Like Thales, who thought everything was made of water,
Water. Interesting.
or Anaximander, his student, who imagined Earth as a cylinder floating in space with the stars as fiery vents.
A cylinder. Wow.
They were starting to use observational logic instead of just relying on myths.
Right. So like proto-scientists in a way.
Exactly. And Anaximander is often called the first astronomer.
Huh. That's cool.
His cylindrical Earth idea was a big step from the earlier, simpler ideas.
So stepping away from flat Earth.
Right.
Okay, and you see this in ancient myths too. It's like early science, but with a story wrapped around it.
Definitely.
I was reading about how important the sun and moon were in places like Mesopotamia and Egypt for predicting the seasons, especially for farming.
Right.
When to plant, when to harvest, when to have festivals. It was all tied to those cycles.
Yeah, the cycles of the heavens were crucial for their lives.
Which led to the first calendars, right? Even the words moon and month are related.
That's right, from the same root.
So there's this beautiful link between how they saw the world and their daily lives.
Absolutely. And, you know, connecting this to the bigger picture, we also see examples of ideas that grab our attention but don't really hold up scientifically.
Okay, like what?
Like the theory that aliens built the pyramids.
Oh, yeah, that's a classic.
Right, this image of ancient astronauts coming down and being master builders.
It's a popular one.
It is. It's really captured the public imagination, but, you know,
Yeah.
there's no real evidence to support it.
Oh, yeah. The aliens built the pyramids thing and Stonehenge, too. It's like, for some people, it's more exciting to think about E.T. phone home or, build a giant rock circle than to think about ancient humans figuring things out.
Yeah, it's definitely more sensational.
But I mean, Stonehenge is amazing what those ancient Brits could do, building and rebuilding it over centuries with basic tools.
Yeah,
It was a super important place for them, cosmologically speaking.
absolutely.
Wow.
And this leads us to the historical link between astrology and astronomy.
Okay.
In the early days, they were totally intertwined.
Mm.
Astrology was seen as a science,
Hmm.
used to predict what would happen based on the stars and planets.
Like your horoscope.
Yeah, exactly. The Greeks built on ideas from Mesopotamia, and Egypt came up with the zodiac and the idea that the position of the stars when you were born determined your destiny.
So like your fate was written in the stars.
Right, and it was used to predict everything: wealth, marriage, health.
It's wild to think that even Greek doctors who made some pretty good medical discoveries also thought that different parts of your body were ruled by different planets.
Yeah, they were really into this idea of celestial influence.
Right, but then when you consider how incredibly vast the universe actually is, all those stars and galaxies at distances we can barely comprehend,
It's mind-boggling.
and all the forces at play, like black holes and all that, it makes the predictive power of traditional astrology, which is based on Earth being the center, seem, well, a little less convincing.
Right, a little less likely.
So this shift from an Earth-centered view to what we know now is really a story of key figures and major paradigm shifts.
Totally, people who revolutionized our understanding of the cosmos.
Yeah, we need to acknowledge those who changed how we see our place in the universe.
For sure, like Copernicus with his idea that the sun, not the earth, is at the center of our solar system, the heliocentric view.
That must have blown people's minds back then.
It was a radical idea at the time.
It reminds me of this time, totally made up story, of course, when I was learning to play the ukulele.
Uh-huh.
And I couldn't get this one chord for ages, and then suddenly it clicked. Like, my whole understanding of the instrument shifted. I can only imagine what Copernicus's ideas did to people's understanding of the universe.
Oh, yeah, it was a total game changer. And then you have someone like Giordano Bruno.
Okay.
Unlike Copernicus, who was mainly focused on astronomy, Bruno was a philosopher fascinated by the implications of Copernicus's work.
Okay, so like, what if Earth isn't the center? What does that mean for us?
Exactly. And this led him to propose a truly revolutionary idea: an infinite universe filled with countless planets, maybe even with other beings like us.
Whoa, that's huge, especially for the 16th century, right?
Yeah, it was way ahead of his time.
To think of an infinite universe, it totally challenges the idea that Earth and humans are the most important thing.
Right. It kind of puts us in our place a bit.
So how did that go over with the church back then?
Not well at all.
Oh boy.
The church strongly believed in the uniqueness of Earth and humanity. Bruno's ideas were seen as heresy.
Oh.
He was tricked into returning to Italy,
Yeah.
arrested, and spent 8 years in prison, questioned by the Inquisition.
Yeah.
He refused to recant his beliefs, and the ending was brutal. They clamped his mouth shut, pierced his tongue, and burned him at the stake in 1600.
Wow, that's a dark chapter.
It's a stark reminder of how dangerous it was to challenge those in power, especially the church back then.
So basically, don't question authority. Got it.
Well, thankfully, times have changed, but it's important to remember those who fought for scientific progress, sometimes at great personal cost.
Right, and then there's Galileo, kind of like the tech guru of the Renaissance, right?
Yeah, you could call him that. He was a big advocate for the telescope.
Like the Al Gore of the 17th century with his passion for the telescope.
Uh-huh. Yeah. I like that analogy, and it actually highlights an interesting point.
It's that.
Like with any new tech, there was initial resistance to the telescope,
Mm-hmm.
especially from those comfortable with the old ways.
People don't like change.
Exactly. But Galileo's improvements to the telescope were significant, and he saw its potential beyond just astronomy.
Mm.
He even invented a military compass that was quite successful commercially.
So he was a practical guy, too, not just gazing at the stars.
Right. He was interested in the real-world applications as well.
So it wasn't all about pure science for him. There was a business side, too.
There was,
Yeah.
but it was his astronomical observations that really got him into trouble.
Uh-oh.
He strongly supported Copernicus's heliocentric view, and despite warnings, continued to argue for it, even suggesting that the Bible shouldn't be taken literally on scientific matters.
Bold move.
It was, and it led to his arrest by the Vatican and eventually house arrest for the rest of his life.
Wow. So speaking, your mind could really get you in hot water back then.
It could, especially when it came to challenging the church's authority.
It really makes you appreciate how far we've come in terms of scientific freedom.
It has those struggles and shifts in thinking that paved the way for our understanding today.
Yeah, now when we look at our cosmic neighborhood, our solar system, it feels almost, well, normal, even though it's anything but.
Right. And when you grasp how massive it is, it's pretty humbling. Our sun, which seems so huge to us, actually contains 99.86% of all the mass in the solar system.
Whoa, so everything else, all the planets, moons, asteroids, comets, it's all just a tiny fraction.
Exactly. We're just a small part of a very, very big system.
Makes you feel pretty insignificant, huh?
In a way, yeah, but also kind of connected to everything.
True. And speaking of our place, Earth is nestled in this thin layer we call the atmosphere. It's like our planet's protective bubble.
It is. It's a blanket of gases that gives us air. Water shields us from harmful radiation, regulates temperature, all the things that make life possible.
Right. So kind of important.
Absolutely essential, but it's also a delicate balance. And as you go up through the layers, things change dramatically.
Yeah, from breathable air to thin oxygen and intense UV radiation.
Exactly.
Hence the need for sunscreen, even on a cloudy day.
Always a good idea.
And then there are the planets themselves, each with its own unique character. You could say
Yeah.
you've got the inner rocky terrestrial planets like Mercury, Venus, Earth, and Mars. And then the outer gas giants like Jupiter, Saturn, Uranus, and Neptune and Pluto, kind of doing its own thing way out there.
Pluto is definitely the odd one out.
Yeah.
Much smaller and icier than the other outer planets.
Yeah.
And its orbit is a bit strange, too. It actually has more in common with the moons of the outer planets and the icy objects in the Kuiper Belt.
The Kuiper Belt? What's that?
It's a region of icy bodies beyond Neptune and Pluto.
Okay.
And because of Pluto's similarities to those objects, there's been a lot of debate about whether it should even be called a planet anymore.
Right. Like, is it a planet or a dwarf planet or what?
Exactly. Even major planetariums have changed how they classify it.
Wow. So Pluto's status is still up in the air.
It is. It reminds us that our scientific understanding is always evolving.
True.
Yeah.
Sure. Now let's talk about our star, the sun. It's easy to forget how powerful it is, this constant source of energy radiating all sorts of things.
Yeah, we see the visible light, feel the heat from infrared radiation, and sometimes get a sunburn from ultraviolet rays.
And those aren't the only things it sends our way, right? There are radio waves, microwaves.
Right, and even higher energy particles.
Yeah.
But thankfully, our atmosphere blocks most of that.
Otherwise, we'd be in trouble.
We would. And the sun also has features like sunspots, those cooler, darker areas on its surface.
Sunspots, what causes those?
They're caused by intense magnetic activity within the sun.
Interesting.
They're actually cooler than the surrounding areas, which is why they appear darker.
Huh. That's counterintuitive. I would have thought they'd be hotter.
Yeah, it's a bit surprising, but that's how it works.
It's funny to think about ancient beliefs about the sun. I remember reading that the Egyptians had a whole religion based on sun worship.
Oh yeah, with Rama's sun god?
Right. And in China and even parts of Europe, people believed that making loud noises could help the sun if it was in trouble.
Uh-huh. Like a cosmic pep rally.
Right. Imagine thinking you could save the sun with noise.
It's pretty amusing from our perspective.
And then there are phenomena like the aurorae, those amazing light shows in the sky.
Beautiful, aren't they?
They get their different colors from charged particles from the sun hitting different gases in our atmosphere.
Exactly like oxygen and nitrogen, each giving off light at specific wavelengths.
So it's like nature's own laser show.
That's a great way to put it.
Now let's zoom in on the inner planets for a sec. Mercury being closest to the sun sounds pretty extreme.
Oh yeah.
Boiling hot during the day, freezing cold at night with barely any atmosphere.
Not a very hospitable place.
And Venus, named after the goddess of love, is ironically a total hellscape.
Yeah, a runaway greenhouse effect.
Right, a thick atmosphere of carbon dioxide and incredibly high temperatures.
Not exactly a romantic getaway.
Definitely not. And then there's our home Earth, the little blue marble with just the right conditions for life.
A very special place.
And its history is mind-blowing, from the first life in the oceans to fish crawling onto land, the age of dinosaurs, mass extinctions. It's a wild ride.
It is a testament to the resilience and adaptability of life.
I always find the asteroid theory for the dinosaur extinction so fascinating, even though there's still some debate about it.
Yeah, the evidence for a major impact around 65 million years ago is pretty compelling.
Like, what kind of evidence?
Well, there are high levels of iridium, an element rare on Earth, but common in asteroids found in rock layers from that time. And there's a possible impact crater in the Yucatan Peninsula.
Whoa, so a giant space rock slammed into Earth and wiped out the dinosaurs.
It's the most likely scenario. But some scientists think that climate change might have already weakened the dinosaurs, and the asteroid was the final blow.
So like a 1-2 punch.
Exactly.
And then there's our faithful companion, the moon. It's amazing to think it probably formed from a giant collision early in Earth's history.
Yeah, a massive impact that sent a chunk of Earth into space.
And even something as simple as how long a month is for the moon is a bit complex.
Right, there's the synodic month, which is based on the moon's phases,
Okay.
and the sidereal month, which is its actual orbital period around Earth.
So 2 different ways of measuring a month.
Exactly, and the synodic month is a bit longer because while the moon orbits Earth, Earth is also moving around the sun, so it takes the moon a bit longer to return to the same position relative to the sun.
Okay, that makes sense. And then there's the blue moon, which isn't actually blue, right?
Uh-huh. No, it's not.
It's just a term for the second full moon in a calendar month.
Yeah, it used to refer to something impossible, but the meaning evolved over time.
So if someone says once in a blue moon, they mean it's really rare.
Exactly.
Okay, now quick hop over to Mars with its giant volcano Olympus Mons and that massive canyon system, Valles Marineris.
Mars is definitely a planet of extremes.
And then the gas giants, Jupiter with its great red spot, a storm bigger than Earth, and its many moons.
Jupiter has over 70 moons that we know of.
Wow. And one of them, Ganymede, is even bigger than Mercury.
That's right. It's the largest moon in the solar system.
Okay. Then Saturn with its stunning rings, Uranus, which was almost named George.
Haha, can you imagine?
The planet George.
He doesn't quite have the same ring to it.
And Neptune, and finally Pluto, way out there in the cold, dark depths.
It's quite a diverse collection of worlds out there.
It is, but it's not just planets, right? There's all
Mhm.
that other stuff floating around. Asteroids, comets, meteoroids.
Yeah, all of the debris left over from the early solar system.
It's like the cosmic junk drawer.
Haha, that's a good way to put it.
So what's the difference between all those things?
Well, asteroids are generally rocky or metallic.
Okay.
Comets are often called dirty snowballs made of ice rock and dust.
Hmm.
And meteoroids are smaller fragments that can burn up in our atmosphere, creating those streaks of light we call shooting stars.
So shooting stars aren't actually stars.
No, they're just tiny bits of space debris burning up.
That's cool. And where do comets come from?
Well, long-period comets are thought to come from the Oort cloud.
The Oort cloud.
It's a theoretical region far beyond the planets, a giant sphere of icy bodies.
Wow. So far out there.
And periodic comets, the ones that come back regularly, are believed to come from the Kuiper belt, which we talked about earlier.
Right beyond Neptune and Pluto.
Exactly. And it's interesting that the Kuiper belt was predicted long before we had evidence of it.
So scientists were like, it should be there, and then they found it.
Yeah, it's a great example of how scientific theories can lead to new discoveries.
And some of these comets have had a big impact on human history and culture.
Definitely, they were often seen as omens, good or bad, depending on the culture.
On a Halley's Comet.
Right, it's been observed for centuries and has been linked to various historical events.
And then there was that whole Heaven's Gate cult thing with Comet Hale-Bopp.
Yeah, a tragic example of how these celestial objects can be misinterpreted and lead to dangerous beliefs.
Definitely a reminder to approach things with a healthy dose of skepticism.
Absolutely. But let's not forget the potential danger of impacts from these cosmic wanderers.
Oh, right. Asteroids hitting Earth.
Yeah, we found evidence of impacts throughout Earth's history,
Yeah.
from the Tunguska event to major craters.
So it's not just science fiction, it's a real threat.
It is a reminder that we're not completely safe from these cosmic events.
Makes you think twice when you see a headline about a near-Earth object.
Yeah.
Okay, let's zoom out even further past our solar system to the stars themselves. The sheer number of them is mind-blowing.
It really is. Our sun is just one of about 200 billion stars in our galaxy, the Milky Way.
200 billion, wow. And we can only see a tiny fraction of those with the naked eye.
Right. And our Milky Way is just one among billions of other galaxies in the observable universe.
Billions of galaxies, each with billions of stars. It's crazy.
It is. And the distances involved are hard to even comprehend: light years.
Right.
Parsecs, they make our everyday sense of scale seem ridiculous.
Yeah, I mean, a light year is the distance light travels in a year, and light is the fastest thing we know of.
Right. It travels at about 186,000 miles per second.
So a light year is a huge distance.
Enormous. And when we look at a star that's 10 light years away, we're seeing light that left that star 10 years ago.
So we're looking into the past.
We are. It's like a time machine.
That's amazing.
And the Andromeda Galaxy, our closest large spiral neighbor, is about 2.9 million light years away.
2.9 million. That means the light we see from it started its journey before humans even existed.
Exactly. It really puts things in perspective.
It does. And there are all sorts of different galaxies, right? Not just spirals.
That's right. There are irregular galaxies like the Magellanic Clouds and dwarf galaxies like the Sagittarius dwarf orbiting the Milky Way.
It's a vast and diverse cosmic landscape.
It is full of mysteries and wonders.
Well, so what's the fundamental force that holds all of this together? The glue of the universe, so to speak.
That would be gravity. From Aristotle's early ideas to Galileo's insights to Newton's universal law of gravitation, we've come a long way in understanding this force.
So it's the same force that makes an apple fall from a tree that also governs the motions of planets and stars.
Exactly. And Einstein later refined our understanding with his theory of general relativity, which describes gravity as a warping of space and time.
It's amazing how one simple observation, like an apple falling, can lead to such profound insight.
It is. It's a testament to the power of human curiosity and ingenuity.
Now let's talk about our desire to actually go out there into space. It's a dream that's been around for centuries, from myths to early attempts at flight.
Yeah, humans have always wanted to reach for the stars.
I remember reading about this Chinese inventor named Wan Hu, who tried to build a flying machine with gunpowder rockets.
Oh yeah, that didn't end well.
Not at all, but it shows that urge to explore even with limited technology.
Definitely. And the invention of the telescope was a huge step forward, even though its initial uses were more for military purposes.
Right, Galileo used it to spy on enemy ships.
But he also pointed at the sky and made groundbreaking discoveries that fuel our desire to travel to space.
And then came the space race, driven by the Cold War rivalry between the US and the Soviet Union.
It was an intense competition that pushed both sides to achieve incredible things.
Sputnik was the starting gun, right? That little satellite that freaked everyone out.
It did. It showed the Soviet Union's capabilities and kicked off the space race.
And then they sent Laika the dog into orbit.
And then Yuri Gagarin, the first human in space.
The US responded with the Mercury program and the ambitious goal of landing on the moon.
It was a bold goal, but they achieved it.
Yeah, Apollo 11 in 1969 with Armstrong, Aldrin, and Collins, a giant leap for mankind.
A truly historic moment.
I read that the Soviet Union also had a lunar program, but they never made it to the moon.
That's right. The U.S. won that race.
But the space program has always been controversial, right? With questions about its costs and whether it's worth it.
Yeah, it's expensive, and there are always other priorities competing for funding.
NASA estimated the Apollo program cost about $25 billion.
A lot of money. But there have been many benefits, too. Technologies developed for space that we use every day.
Like what?
Smoke detectors, laser eye surgery advances in medical imaging.
Oh, wow. So those things came from the space program.
They did. It's called spin-off technology.
It's easy to forget about those benefits when you're thinking about the cost.
Right, but they're significant.
And I was surprised to learn about the Mercury 13, those women who trained as astronauts but were never sent into space.
Yeah, it wasn't until 1983 that Sally Ride became the first American woman in space.
It shows that progress isn't always linear.
Definitely, there were a lot of barriers for women in those early days of space exploration.
Right. And then there was the space shuttle program with its triumphs and tragedies like the Challenger disaster.
Terrible loss.
But there were also amazing moments like John Glenn returning to space at age 77.
It was inspiring to see him go back up there.
Now we have the International Space Station, a permanent human presence in orbit, and even space tourism is starting to take off.
It's an exciting time with new possibilities opening up.
It feels like we're entering a new era of space exploration, maybe driven more by private companies.
Yeah, commercial spaceflight is definitely on the rise.
But alongside those physical journeys, there's that big question, are we alone?
The search for extraterrestrial intelligence.
It's a question that's fascinated humans for centuries.
And now we have the tools to start looking for answers.
So how are we doing that?
Well, we're sending probes to explore other planets and moons, looking for signs of life.
Okay.
And we're using radio telescopes to listen for signals from other civilizations. Exactly, it's a long shot. But the implications of finding any evidence of extraterrestrial life would be huge.
It would change everything, our understanding of the universe, our place in it, everything.
It would be one of the most profound discoveries in human history.
Okay, so now let's talk about the really big picture cosmology, the origins and fate of the universe itself.
The ultimate questions.
It's humbling to think that even brilliant minds like Kepler and Newton tried to calculate the exact date of creation.
Yeah, Archbishop Usher's calculation of 4004 BC was widely accepted for a long time.
But then science came along and revealed a much older and more dynamic universe.
Right, the Big Bang Theory is now the leading model describing the universe as expanding from an incredibly hot, dense state about 13.8 billion years ago.
It's hard to even wrap your head around that.
It is, but the evidence supporting the Big Bang is quite strong.
Like what kind of evidence?
Well, there's this cosmic microwave background radiation, a faint afterglow of the Big Bang.
So like an echo from the beginning of the universe.
Exactly.
Yeah.
And the observed expansion of the universe, the fact that galaxies are moving away from each other.
Okay, so the universe is still expanding.
It is, and it seems to be accelerating.
Whoa, so what does that mean for the future?
Well, that's one of the big questions cosmologists are trying to answer.
It's amazing how the more we learn, the more questions we have.
That's the beauty of science. It's a never-ending quest for knowledge.
So, from wondering what the moon is made of to pondering the ultimate fate of the universe, our cosmic curiosity just keeps growing.
It does, and it drives us to explore, to learn to push the boundaries of what we know.
So, as we wrap up here, remember that feeling of looking up at the night sky and being filled with wonder.
Yeah.
Now, with a few more cosmic concepts bouncing around in your head, what do you think is the most compelling mystery out there waiting to be solved?
Oh.
Is it the question of other life, the nature of dark matter and dark energy, or something we haven't even imagined yet?
So many possibilities.
This has been a brief dip into a vast ocean of knowledge, and there's always more to discover. So keep looking up, keep asking questions, and keep exploring.
Absolutely. The universe is full of wonders.
Thanks for joining us on this deep dive.
It's been a pleasure.
And until next time, keep those cosmic questions coming.
See that?
Bye.